Hey everybody, I'm back with an example of the second derivative test. Here we have a function y equals x plus 16 over x. We'd like to know what its critical values are, and then we'd like to classify each one as a local max or a local min. Now, of course, we have two different ways of doing that, the first derivative test and the second derivative test. Here we're going to opt for the latter. So, finding critical values is a first derivative question. We need to take a derivative here, dy dx equals 1, so plus 16x to the negative first is how I'm doing this. To differentiate x to the negative first, the power comes down. I reduce the power by 1. So 1 minus 16x to the negative second. For critical values, I'm interested in values where this derivative either is 0 or does not exist. Now, it does not exist when x is 0. This is 16 over x squared. However, that's not a critical value. Why? Because it's not actually a value in the domain of the function. In order to be a critical value, an x value has to be able to be plugged into the original function, just not the derivative. So what we really need to ask now is, where is this equal to 0? 0 equals 1 minus, let's rewrite this as 16 over x squared. It'll be a little bit more clear what we're doing. We write it that way. I'm going to move the 16 over x squared to the other side. Multiply both sides by x squared. So 16 is x squared. Take the square root of both sides. Don't forget my plus minus. And I get x equals plus or minus 4. Great. So those are going to be my only critical values. Let's label those. See these critical values. Now, the second derivative test is going to allow us to classify these. We're going to take the second derivative of our function. We're going to plug in the critical values. When we have a second derivative that is negative, that's going to tell us that the critical value is a local max. If the second derivative is positive, that's going to tell us that the critical value is a local min. So the second derivative here is relatively quick. The 2 comes down, negative 2 comes down rather, and I get 32x to the negative third. D squared y over dx squared. Great. Again, it might be helpful just in terms of our intuition to rewrite that as 32 over x cubed. Doesn't make a huge difference. So let's plug in our first critical value. Let's plug in x equals positive 4. Now again, I don't care what the value of the second derivative is here. I just care whether it's positive or negative. When I plug in a positive number here, I get a positive number back. So that tells us right away that x equals 4 is a local minimum. M-I-N, minimum, by the second derivative test. Next, let's plug in the other critical value. X equals negative 4. When I plug negative 4 in here, I get 32 over negative 4 cubed. That denominator is going to be negative. A negative number cubed is still negative. So the second derivative is negative there. So x equals negative 4 is a local maximum. Simple as that.